expected value is defined as the value that you are expected to get after a certain number of trials. In this case, rolling a die, to calculate it, we would add up the possible values of it and then divide by the probability. In this other image, we can see that there's a 1/6 chance of getting a 1, 1/6 chance of getting a 2, and so on until 6, until we get our final answer of 3.5. We multiply the value of the case by the probability that that case happens until we get our final answer, and then we add them together. Unlike other things in life, which often expectations are placed at an exponential rate, expected value grows at a linear pace, like corn. This is what makes it so useful, because there's something called linearity of expectation, which can help simplify a lot of math problems. When given two or more, in this case 2, independent or dependent events, we can write the expected value of x plus y as the expected value of x plus the expected value of y. For example, if the price of the pink corn and the price of the yellow corn are both dependent on the rolls of two independent dice, we expect each of them to have a value of 3.5. So their total price is expected to be 7, even though each die is independent of the other roll. So how is this derived? How do we prove this? Well, the algebra is a bit complicated, so we're going to dive in it a bit deeper at a later time. But essentially, the concept of the proof is to assign cases and assign probabilities of that specific case happening. And after a bit of manipulation, we would finally get the desired linearity of expectation, that the formula that we have already seen. So let's see this in action with a problem that involves corn. Let's say that each corn is equally likely to be pink or yellow. And in this case, we're trying to figure out the number of pairs of corn to adjacent corns that are both yellow. What is the expected number of pairs that are both yellow corn? There's not a lot of ways we could start off, so we just start simply by computing one pair's probability of having two adjacent yellow corn. So we have 1/2 probability of the first corn in the pair being yellow, and then we also have 1/2 chance of the second corn in the pair being yellow. So that means that we have 1/2 times 1/2 equals 1/4 chance of both corn being yellow. So this pair of corn has a 1/4 chance of both being yellow, as opposed to one being pink or both being pink. So what does this mean? If we use casework, we still have a bit of a headache because we have to calculate how the first pair affects the second, thirds, and the rest's chances. But if we used our prior linearity of expectation formula, we can make it a lot easier. For now, we don't have to worry about whether the cases are dependent or not. It doesn't matter, because for each of the 7 pairs, the expected value is 1/4. And since there are 7 pairs, we would expect that there are 7 times 1/4 of adjacent yellow corns. So in total, you would expect 7 over 4 pairs of adjacent yellow corn. And this is why linearity of expectation is so powerful. It works for dependent events as well as independent ones. But remember, with great power comes great responsibility. So make sure that you use this formula correctly. And with expected value, you also know that there are great expectations. Anyways, thank you for watching, and I hope this video was interesting to you.